So this was the slide. I ask you, what do you think is the key practices, technologies and approaches, yeah, to handle security threats in different landscapes. Okay, I think I need to go that other kind of slide. Yeah. Okay, so some of it you already have said, so we will be quick on those. Okay, so encryption, yeah, some of you already said, always have encrypted methods. Okay, and strong passwords, and some of you said multi-tier security, yeah, so multi-factor authentication, role-based access. I think some of you already said that, yeah. Firewalls, I think we discussed it, yeah, and IDS is intrusion detection system, yeah, so it's like detecting some anomalies. Backups and disaster recovery, I think this is something nobody told. So backups and disaster recovery, yeah, like we were talking in terms of ransomware, yeah, that if you don't give the money to attacker, they are going to cause denial of service, yeah, let the whole system down, or stealing all the information, yeah. So if it's like someone tries to erase all the information, you should have some backup plans, yeah. That's why you may see like data center companies, they keep the data at two places, yeah. So if one goes wrong, they can make the system up with other backup, and there can be also disaster recovery, yeah. So again, kind of a backup, yeah. So basically you can get your data back. Regular patching and updating, this is something again I think nobody said, but you might see like there is always some kind of updates through the software, yeah, update this version to this version, that version. So I think typically everybody ignores it because it's a lot of hassle, but it's always recommended to do it because these kind of patches are kind of going to fix some kind of advanced system problems, yeah, advanced attacks that might happen, because you know the attacks is not like this is already well established, but they keep developing. Okay, so when the companies know like this is a new kind of attack that may happen, so they update their software. Okay, so that can to kind of handle that. So regular patching and updating is important. I think this one someone already pointed, I think awareness, so this is just that. And security clearance of people, yeah, so you remember we said there could be insider threats, yeah. So there are some key positions, like someone is going to manage the whole IT system, has kind of root access, so that kind of person must have security clearance, yeah. I think in lots of government jobs also, yeah, you see like persons should not have any criminal backgrounds or no cyber crime or something. So you can rely on that, yeah. Still something can happen, but it's kind of an assurance that it's less likely to happen. And a strong defense is always desired. That means you must be able to detect an attack and immediately mitigate it so that the consequences are not very kind of fatal. Okay. Good. So what are now the key takeaways, yeah, from just this introduction to secure computing? So security is everyone's job, yeah. You cannot say, okay, I leave it to the people where I log in, yeah, because they keep suggesting you put a strong password, yeah. You can think even more stronger password, yeah. So it's our job as well. I know we know it's hassle, right? Keeping so many passwords for so many websites, it's like painful to remember, yeah. But there's no other way. So this is the one we have to do. And CIA, you remember confidentiality, integrity, and availability. This is the foundation of a secure system. And we need basically the technology, processes, and awareness for a strong defense. Yeah, so it's not just on the technology. We need process like rule-based access, like in the previous slide I said, some security clearance for the people who are going to deal with the systems, and awareness as well. Yeah. So for example, if you type your kind of ID password somewhere, you must kind of be aware what exactly is going to happen with that. Yeah. For example, you sign up to a lot of social media sites, right? So you should be aware like how your data is going to be used and all those kind of things. Okay. Good. Any questions on that? Introduction to secure computing? No? Okay, so with this we will move to introduction to sustainable computing. Okay. So what is sustainable computing? Again, you can simply think of like you are going to balance performance, efficiency and the planet. So three entities together. Okay. So performance, like I said, it is always desired. Yeah. So you cannot live with a system that is very, very slow. Okay. And efficiency, like again there are efficiencies around other metrics. Yeah. Like energy efficiency, yeah, reliability, those kind of things. So when you are meeting your performance and also achieving efficiency in other metrics, you should think of the planet as well. Yeah. So maybe you are achieving very high efficiency, yeah, or very high performance, but you may negatively impact planet. Okay. Maybe there is huge carbon footprint around it. So sustainability kind of encompass all these things. Okay. We will come to more formal definition a bit later, but just think, I think only this term has to be considered. Yeah. Kind of the planet, okay, or earth, or just the campus, you can say. Okay. So why sustainable computing matters? Remember, like we said, like why secure computing matters. There is like $10 trillion cost to fix. Yeah. So now about sustainable computing. So if we look ICT sector, yeah. So ICT stands for information and communication technology. Yeah. So it's all around computers. So they contribute 3 to 4% of global greenhouse gas emissions. Okay. So the greenhouse gas is like carbon dioxide plus some other gas. Okay. And this can be in many form. Yeah. So for example, when we get our phone or laptop, so it is first kind of manufactured in a factory, okay, at a very high temperature, and in each of these devices there are like 20 to 30 kind of materials, and they are sourced from many places. Yeah. Like cobalt is the main material, this comes from Africa. There are so many other materials, they all come from different place. Yeah. And then they are kind of given different form, yeah, like at high temperature, so then they release some gas. Okay. And then the final product comes, and then it is transported to us, and then we start using it. Yeah. So if you look all the electronics from like kind of a resource procurement, manufacturing, transportation, then operating, maybe 4 to 5 years, yeah, each electronic. So it's around like 4% global greenhouse gas emissions. Okay. So this is the statistics at the moment. Remember, we said there are around like 28 billion electronic devices now, but there will be like 50 billion in a couple of years, and we said in a decade or two there could be trillions. Yeah. So imagine how this can increase. Yeah. Just in 2 to 3 years this can be 8 to 10%. Yeah. And then in 20 years maybe half of the world's electricity has to go in electronic devices. Yeah. And there is also some data that says, like, you know, the data centers, they take electricity like the whole of the country, like Spain or Australia. So how much energy is consumed into Australia or Spain, that much energy goes into data centers. And these companies want to expand basically at exponential rate just to capture the market. So again, there will be increase in number of electronics, a number of servers, data centers. So this greenhouse gas emissions is going to be a lot. Yeah. Okay. And about data centers, I already said. Yeah. So they are high in demand, and they also consume a lot of energy, yeah, like I said, whole of Australia, yeah, like that goes in the data center. Okay. But why we do sustainable computing? So it's basically going to do many benefits. First could be cost savings, yeah, like if your data center is not taking huge amount of power, you can save energy bills. Another thing could be compliance, yeah. So at the moment there are not of regulatory compliance, but you can see like you can might be here, yeah, like there's net zero goals for different countries, yeah. So they all want to rely on maybe kind of renewable energy and all those kind of things, yeah. So reduce the global greenhouse gas emissions, okay. And ethics is another important thing. So like everybody should contribute it. So the next generations that are coming, the planet should be livable for them, yeah. You can imagine there are a lot of places already on earth, its temperature is so high, yeah. So even you may imagine when we were child and now the rise in temperature is a lot, yeah, and this is going to increase. So everybody has to think in sustainable way, okay. So just imagine like we have trillions of electronics, and then how much electricity in the whole world is going, half of that is going to electronic devices, yeah, that's too much, yeah, okay. That is why you can see like there are a lot of regulations coming, and if someone is more carbon neutral, they are incentivized, like they can get some carbon credit and all those things, yeah. EVs are coming because of that, so you have less gas, yeah, okay. Okay, let me see that slide again. This one is done. Okay, I think briefly we have discussed, but I just wanted to kind of have your view. What do you think is sustainable computing? If you can think maybe slightly different what we talked, yeah, that will be more interesting to discuss, yeah. So some kind of I'm looking more formal definition, yeah. So when I was saying what is secure computing, so it was about ensuring CIA, yeah, confidentiality, integrity and availability. So can you say something like that, maybe ensuring this? Yeah.
Ensuring efficient energy consumption.
Yeah. Okay, let's read, yeah. Sometimes actually a lot of interesting thing comes from discussions, yeah. So long lasting and eco-friendly, definitely, yeah. So you want maybe your laptop to last. I think there are some researchers, they want to propose in a way like, you know, your electronic lasts for whole life, 100 years, and it consumes maybe no energy or just solar, something that is enough from the solar. This is the best, right? Then you're not burning any fossil fuel, yeah. Okay, long lasting, eco-friendly, good. Focuses on minimizing the risk to planet. Yeah, this is the, yeah, I would say that, yeah, this is what we want, right? We want to do something for computing devices and it should have low risk for the planet, or it should have no risk for the planet, okay. So producing and using computing devices in a way that causes minimal effect on resources of the planet towards a net zero effect. Okay, I think if you put that answer in the question, you get 100 marks, yeah. This is like, yeah, quite formal definition, good, yeah. But I think lots of definitions are kind of around the same line, so it's not like only one definition is perfect, yeah. Could be, yeah, that one is also good. The practice of designing, manufacturing, using and disposing of for optimal use. Okay, so this one is very much matching to the slide I have. Next one, where I have put my definition. Okay, okay, yeah, good. That's nice definitions to see. Okay. So the okay, another one with finite planet and finite natural resources, computing cannot be infinite in resource consumption. That's correct, yeah. Okay, I think it's kind of coming along the same lines, yeah. So you can see there is a lot of this mineral war, right? Mineral deals, yeah. So I don't know if I should say because it's been getting recorded, but countries are fighting for minerals, yeah. US wants some Ukraine minerals, yeah, because there are a lot in China, and lot of these are going to be used in basically computing devices, yeah. So there are limited minerals, yeah. I think at the moment a lot of minerals that come in computing devices, most of them are from Africa, yeah. I don't know if you have seen any videos or something. The kind of mining that happens there, it's kind of very unfriendly or environment where people work in. So it gets everything procured mostly to kind of China or Taiwan, yeah. This TSMC, you might know, Taiwan Manufacturing Semiconductor, yeah. So they produce all the chips for a lot of companies, okay, yeah. Definitely there is limited resource. That is why you can also see there is a research to have computers based on some other device, yeah, not on electronics, yeah. So some other kind of materials. So material scientists are working on all the directions. So having computers from other materials that are available in abundant on the earth, yeah, not just semiconductor. Okay, good. So let's now look my definition, and I think I said it matches to one of it, right? Yeah. So designing, operating, and disposing of computing resources with minimal environmental impact. I think this one matches to one of them very closely. Yeah. Okay. So when you design, when you operate, when you dispose your electronics, always think of having minimal environmental impact. Okay. You can't do the designing, yeah, but some of you do research into kind of making a new chip, yeah, for a specific system. Then you can always think of like how you use minimum hardware, no need to use so many hardware, okay. And then when you are operating it, making sure it does not take a lot of power, yeah. For example, my laptop, yeah, you can see there is some brightness level, yeah, and there is some frequency at which the processor is running. So my brightness should not be the full always, yeah, and my frequency of the processor should not be the highest, otherwise it's just taking more and more power, okay. Similarly everywhere, yeah, wherever electronics are used, just find the most appropriate level so that you can deliver what is needed, but do not over consume anything, okay. And examples, I think like Dr. Momita said, energy efficiency when you are operating, hardware life cycle management. I think this is something, there is a lot of research happening, but it's very less in practice, yeah. For example, if something goes wrong with my phone, so there's no life cycle management, yeah. I think on internet, on Amazon or maybe on Flipkart, you can see there are some refurbished phone or something, right. That is some sort of life cycle management. If something goes wrong, you kind of refurbish it, right. But there is also a way, if something goes wrong, if you can't refurbish, maybe by replacing some computing part, you can remanufacture it, yeah. And there is another step, if you can't remanufacture, you can basically recycle it, yeah. So crush everything and extract all the useful parts, okay. So this kind of things has to be established, yeah. And there's another important thing like long lasting electronic, yeah, someone said like what we can do. So this maybe I want my phone to last for like maybe 10 years or something. Like I said, not everybody wants, yeah, everybody wants to replace it, but if it's going to last like 10 years, how the companies are going to make profit, yeah. So it's not simply just extending the lifetime of electronics. It's a lot of things are around it, yeah. So you have to change some business model and everything, yeah. So maybe companies charge a lot of money at the beginning, but if anything goes wrong with it, they have to basically replace it or repair it, yeah, and then there could be some kind of economy around repair, yeah, or replacing. So if you put any say any company, your phone, laptop must last 10 years, then they are definitely going to kind of make sure, yeah, it will last longer, they will repair or something, but then they want initial upfront cost a lot, yeah. So you may know, like the aeroplane engines that Rolls-Royce make. So you can see, like, there is a lot of orders of aeroplanes, right, but these engines cannot be made so frequently. So Rolls-Royce, like this fighter jet engines model is more on this one, like initial lot of upfront cost and then more around repairing. So they charge a lot of money around repair, yeah. So so basically aeroplane's engine is not changed every 2 years or something, yeah, it lasts many years, okay. So something like that. So that something like that has to be done, but I think it's still far away, yeah, because things are available. Imagine there is no silicon available, then this phone will be maybe 1 lakh rupees, and then these things will start happening, okay, yeah. And responsible e-waste handling. So later on we are going to see, so there is lots of electronic waste that happen. So how we can make sure it is done in a responsible way, yeah. So maybe simply not throwing my phone, rather using it for some other purpose, yeah. Maybe it's just data entry logging, yeah. Maybe some in a supermarket someone can use it for some purpose, yeah. Or maybe I can use its camera simply to monitor something, yeah. So if it's a kind of repurposing, yeah, you can do the repurposing of the electronics, yeah. Okay, so again here we have, you can say, 3 pillars to balance. So we have environmental sustainability, so we have to reduce carbon footprint. A bit of this we have discussed, economic sustainability. So again we need lower costs and improve efficiency, and we discussed a little bit of economic aspect, yeah, how you can basically have some economic policies around it. Social sustainability should also be there, so there should be fair labor and digital inclusion, okay. So these are the things that we need to kind of do so that we can do sustainable computing, okay. So what are the key environmental challenges, okay. So one, like I said, data center energy use, yeah, it's like I said, whole Spain that is taking electricity, same amount goes in data center. So how we can handle that? So that's the challenge. Electronic waste is another challenge. High resource consumption in manufacturing, yeah, like I said, there is lots of resources in manufacturing. So how do we make sure we take less resources, yeah, like we don't put so many things into the same electronics, yeah, if it's not needed, yeah. And the water uses for cooling, yeah. So in data centers or these factories, there is huge kind of amount of water that is used for cooling, yeah. And we have less and less water, or less and less good water, good quality water. If we waste a lot in cooling, then we will have impact on the planet again due to water, okay, yeah. Okay, now let's look some again statistics on carbon emissions by electronic devices, yeah. So if you recall, I said around 3 to 4% is used by all the electronic devices, yeah. But if you look like all the sectors, yeah, maybe like oil industry, car industry, something like that, yeah. So if you look electronics, they are like at 8th position, yeah. So they are in the top 8 sectors, and this one accounts for 50% of the global carbon emissions, okay. So basically if you take all the top 8 sectors, they are like for 50%, yeah, but for electronics, like I said, they are around 4%, yeah, 3 to 4%. So this one I already have said, globally computing devices are responsible for about 4% of world's total carbon emissions, but most of it is for data centers. Yeah. So you can see 1% of the world's electricity is going into rest of the things, like in this laptop, projector, fridge, TVs, smartphones, everything. Okay. Yeah. So now let's look waste by electronic devices. Yeah, like I said, there's a huge waste. Yeah. So to look some statistics, so that the current contribution is over 50 million metric tons of electronic waste annually. Yeah. So this is again worldwide. Okay. So this maybe this figure is not very much relating. So if you want to relate like how much it is per person, so it's around 7 kilogram per person. Okay. So let's say 7 billion people, and then it's each of us have around 7 kilograms of electronic waste every year. Yeah. But like I said, this is not something that we do a lot. There are companies that have huge amount of resources for data centers, facilities and everything. So if you count, it can be like that. Yeah. So for example, like let's say whoever is part of IIT Guwahati, yeah, there are so many computers, yeah, in labs or server rooms, lots of monitoring cameras and everything. Yeah. Even though you are not having all of it, but you are sharing it, right? So maybe each of you have like 2 or 3 kilograms. Yeah. So I would still say like in developed countries it's more, because they have more money to put, but average this is what it comes out. Yeah. Okay. Again here like I'm saying 3-4 kilograms. Yeah. But if you go to a village, maybe there is just 4 laptop in a village, right? So their footprint e-waste is very less. Yeah. But if you average out, this is what it is. So that means some people have maybe 100 kilograms per person. Yeah. Some organizations. Yeah. So this is fastest growing waste stream globally. Yeah. So you have seen this plastic waste, yeah, or those kind of things. So those are still at a lot. Material like building material waste, buildings are like crashed after some time, they are still a lot, but this one is also growing very fast. Yeah. So there needs to be kind of some mechanisms basically how to recycle, refurbish those things in a better way. And this carbon emission and waste will kind of exacerbate further due to exponential increase in the number of devices. Yeah. Like I said, we have around 28 billion, in a couple of years 50, and then many trillions. So this kind of waste will be even more and more, yeah, per person, and thus this is going to significantly impact the sustainability of our planet. Okay. So maybe with trillion of devices, per capita might be 100 kilogram, yeah, electronics. Okay, so now I have this question, so let me go that slide. Okay, so this is some performance issue. Yeah, I said things should be high performance, but maybe it's my laptop or the network. Okay. Okay. Someone already typed. Okay. What? Okay. So what is sustainable computing? That is why. Yeah. Yes, this one is the one. So what can be done to achieve sustainable computing? So you see the trend, right? I said at the moment there is like 7 kilograms electronic waste every person. Yeah. And the data centers are consuming 3% of the world's electricity. Yeah. So if you search on internet, there might be different quotes. Yeah. So I have got it from some source. So if this number of electronics are going to increase like maybe 1 trillion, what do you think can be achieved? Yeah. What can be done basically to kind of achieve sustainable computing? Okay, eco-friendly devices, interesting. So basically that the devices that take less and less power, yeah, or maybe kind of made in a way they don't have a lot of electronics into it, yeah, just needed. Recycling is good, yeah. Be responsible about e-waste individually, yeah, that's good. So I think in the latter part of the lectures we are going to talk more about like what we can do at computing level, yeah. So here as part of the introduction I just want to kind of set up in a broader context, yeah, it's not just about computing, yeah. So recycling and repairing is important, yeah. So leverage it virtualization and cloud and edge computing to optimize resource utilization, yeah. That's good. Basically it's towards kind of doing more with less resources, yeah, so you don't basically have extra resource unnecessarily. Okay, love your digital devices to reduce e-waste, of course, yeah, very good. So merger of chemical industries with electronic waste to recycle, that's interesting one. I think yeah, it's still like lots of electronics, you know, it's just dumped in the sea. So I mean at some point it will start happening when things become expensive and there are less and less material, yeah. So at different levels being mindful of resource uses, recycling, alternative bio resources, reduce power and energy consumption, interesting. Yeah, recycling we should do. Alternate resources, like I said, some material scientists they are trying to develop computers based on other materials, yeah, not really semiconductor, yeah. Reduce power and energy consumption, that's a good one. Raise awareness for eco-friendly computing habits, yeah. So yeah, I think this is good one. So like for example if you go somewhere, your TV is on, just turn it off, yeah, your laptop is on, turn it off. Although all these are like 1% of the world's electricity, but it will reduce carbon footprint, yeah. Or we go out, then all the ACs should be turned off, yeah, they should not be just running here if there is no one, right, yeah. Okay, good. Don't misuse resources of electronic devices and aware to use, yeah, I think this is along the same lines, okay. Okay, that's quite good example, yeah. So I think now you know what to do, yeah. Don't throw your electronics, yeah, try to use as much as possible, yeah. I am using this laptop like from 7 years, so that's why you can see my Wi-Fi modem has died. Although yeah, I have a kind of a backup laptop, but I didn't pack it, yeah. So I try to use as much as possible, and my phone is also I think 6 or 7 years old, yeah. I think there's another reason. I mean there could be two reasons, yeah. One, you are like environmental friendly, another is you don't want to change, yeah, you don't want to update the software and everything, yeah. So I think from both the point of view, yeah. First of all, I don't want to install so many things on a new device, and second, I think like okay, it's new phone is not attractive to me, yeah. So maybe it also depends on your age where you are. If you ask someone like maybe 16 or to like 25-year-old, they may say, oh no, I want this advanced phone, yeah. I think that's not bad, but if you can make sure the one that you are leaving that goes in someone's hand, yeah, and then it is used for a long time, yeah. If it just is thrown in the bin, then that's electronic waste, yeah. Okay, good. Okay, so now I will kind of go through, like you already have said what can be done. So again, like if something has been discussed, we will just move quickly. If there is something new, we can discuss a little bit more, okay. So energy efficiency is first. I think this is something already covered, yeah. You can have low power hardware design or energy efficient uses and processing, okay, yeah. And this is one example here, like Google data centers. Like I said, data centers take a lot of power, yeah, or electricity. So Google used some cooling system based on AI that reduced energy use by 40%. Yeah, so you can imagine, like, this is a huge reduction, right? So if all the data centers do something same, so if it's like 3% of world's electricity, it will be simply like half of that. Yeah, so that's kind of very good use. Life cycle thinking, I think some of you already mentioned it. Circular economy models, I think this is what I discussed. So you have to think recycling, refurbishment, all kind of programs. Okay, but the thing is, this refurbishment has to be incentivized some way, right? If you refurbish, like, what do you get out of it? Maybe you can get some incentive, yeah, or the people who are doing the people who are repairing, they need to be paid higher, right? If they are not paid, well, they will be like, why I am repairing, right? Yeah. Long lasting, we have discussed. Renewable energy adoption, yeah, this is what we have not discussed. So you know, like, there are a lot of renewable energy from solar, wind farms, solar panels and all those, right? And the energy that is stored from them is not always available. Okay, so whenever it's available, that should be used in the electronics. Okay, so, and implement green policies. Yeah, so for example, audit energy uses and incentivize accordingly. Yeah, so I think in some kind of European countries, it's already being done. So every organization is asked, what is your energy use? So like, how much is this computer is using, how much is this office using? So if they somehow can show their energy use is less, they get some incentives. Yeah, so like reduction in their energy bills or something. So again, if you are incentivized for something, you tend to do it more, right? So that is why it's important. Okay, so now some key takeaways. So what is sustainable computing? So it's about achieving efficiency with responsibility towards the planet. Okay, and every choice impacts environmental footprint. Yeah, so whatever you do, if you have electronics around you, the kind of path you choose, it impacts the footprint. Okay, and technology can be part of the solution. Yeah, but it is not the complete solution. You remember we said it's just not the technology, it's like human as well has to be part of it. Okay, any questions? Yeah, any more questions? Yeah, hope you get some idea, like introduction to like secure computing and sustainable computing. Yeah, so I think this kind of material you can find at many places, but this is something like I took from many sources and then combined the kind of work we do as well. Yeah, okay. Okay, so I think we have exceeded the time. The plan was this much we are going to cover in lecture 1, yeah, but I think we have used part of the time on lecture 2. So I think I will try to basically maybe not repeat the things if it is again available in the next slides. Yeah. Okay, so this should be not taking long time because we have only 15 slides for lecture 2. Okay, so for lecture 2, the plan is to basically learn about system design and operation considerations for secure and sustainable computing. Okay, so this is what we want to do, right? Secure and sustainable computing. And when you can basically do that, yeah, so you are designing the system and then you are operating the system or using it. Yeah, so either you can do during the design or you can do during the operation of the system when you are using. Okay, and the focus is mainly secure and sustainable computing. Okay, so the first we will look system design and operation considerations for secure computing, and after this we will look for the sustainable computing. Okay, So again I have put some questions, and sorry I have not put in that format because like I told you, my internet modem has stopped working. Maybe tomorrow I will bring more this kind of questions. Okay. So how security attacks originate from system design and operation point of view. So let's say you are designing your system, or it's being manufactured or designed somewhere, and then you start using it. So how security attacks originate? What do you think? I mean, few things we already have seen, right? When you are operating, someone can put some malware into it, right? That's one way. Yeah. Any other things you can think? I think someone mentioned in the first lecture, like when things are manufactured, someone can insert hardware trojans into it. Yeah. That's another way to originate, yeah, security attacks. Say again? Keyloggers. Yeah, that could be, yeah, one way. So again, if you look the security landscape we discussed, right? We said malware, social engineering, yeah, insider threats, denial of service, yeah. So again, that insider threats can always be there, yeah. Someone in the organization with malicious intention, they can always put a virus in any computer, yeah. So it can originate in many ways, yeah. When basically it's being designed, so someone having bad intention, they can put some kind of extra circuit that can trigger some operation after some time and letting the whole system down, okay. And when you are operating, again someone can insert some malware, and like we discussed, there was a branch of attacks, right? I said side channel attack. Someone can always get his side channel information to get passwords or something, okay. So now let's look some top reasons for security attacks. So I would say, I mean, this is my definition, but you can think from different point of view, yeah. So one thing is, if we are starting with a compromised hardware, yeah. So a system is basically couple of things, yeah. You have a hardware, you have a software, right? And then this hardware is integrated with the software, and then it does something, and then system is operating, okay. So if you get a hardware from, let's say, Intel, AMD, some companies, or NVIDIA, if that itself is compromised, yeah, that has a hardware trojan, yeah, or maybe a circuit that sends information over the Wi-Fi network, yeah, that is a compromised hardware, yeah. So if you start with a compromised hardware, then this is a problem, yeah. Another thing could be, you may start with a compromised software, yeah. For example, you install something, maybe some AI module or something, and that itself is compromised, yeah, or it has some kind of malware into the package, okay. So like I said, think like system has kind of two components, hardware, software. You integrate them to start running the things. If any of those is compromised, you will have security issues, okay. And the next one can be bad actors in the middle of execution, yeah. So when you integrated hardware, software, you are executing something, like I said, now this PowerPoint is running, now it's executing basically, yeah, this program is running continuously. But if there is some bad actor, that means someone tries to get access of my computer, or there could be some other ways to kind of do some kind of attack onto it, yeah, maybe putting some virus in the meantime, okay. So these are the three kind of you can say places where things can happen, yeah. So again, this is my definition, that's how I think, but if you look in the books, everything, they might be in different ways, okay. All right. So think like, do not start with a bad hardware. Again, there is some reputation, right? Like some companies have reputation, that is why you choose that company's hardware. That's the reason. Again, software as well, yeah. You do not install anything on your phone, right? You go Apple Play Store or Google Play Store, yeah. You can get lots of APK files on the web, you can always put into your phone, yeah, but then something may go wrong, okay, yeah. And if something happens in the middle, we already have seen, okay. So what should be done to kind of basically to stop these? Any thoughts? I think some of it we already have discussed, right? So maybe that's I said, yeah, I will not try to repeat, we will go quickly, but maybe again thinking like we already have discussed few things, what extra do you think is needed to achieve this secure computing from the point of view of design and operation? Yeah, maybe let's look what I have, yeah. So you can always do something called like network and device segmentation and isolation, yeah. So you might have seen like there is some technologies in some products, I will come to that later. So you know, if there is a kind of more secure data flowing, so that kind of network can be isolated and not everybody should be given access to it, yeah. So that is kind of segmentation and isolation of the critical parts, critical data, critical system, yeah. Even it comes to critical people as well, right? So like director of the institute, registrar of the institute, yeah, they live in a more secure place or something, yeah. It same happens with systems or data, yeah. If it is more secure, not everybody will have access to it and they will be isolated from rest of the things, okay. And we can also have trusted execution environment. I don't know if you have heard, ARM has developed something called like trust zone, okay, and Intel has developed something like Intel SGX, okay. So this is something like in your phone, let's say typically you have 8 processors, yeah. So they kind of develop some zone, like 4 of the processors will be one zone, another 4 will be another zone, and this first 4 will be called like secure zone. So anything confidential that happens has to be in the secure zone, rest of the things can be on the non-secure zone. Later on I am going to kind of have more detailed approach that we have developed in our group, how these things happen and how then attack can happen and how the defense can happen a bit later, yeah. But this is what you can think of, yeah. So kind of trusted environment where not every application will have access to it, yeah, only kind of more authenticated applications will have access. End-to-end encryption we have seen, data encryption at rest and in transit, yeah. So it's like when data is just sitting, then also encrypt it, and when it is moving or going from one place to another, then we encrypt anyway, okay. Regular updates for OS, firmware and apps, we have seen it, yeah, but the one thing to do is always test patches before deployment, yeah. I think this is not everybody can do, so you need to have some kind of expertise into it. That is why when we get some software update or something, that is already kind of tested, yeah. Maybe if it's provided by some security company or if it's some update from someone like an app, it's already tested by Google apps, yeah, or you can say, yeah, other companies. And appropriate access controls, we have seen it, and continuous logging and monitoring, yeah. So this is important, but again it depends on the situation. If you kind of always monitor, like in my laptop, what's happening, yeah, if it's monitoring like every minute, I'm just running my PowerPoint slide, yeah, but this is not kind of very useful, yeah. But it could be like if some attacker tries to access my system, then if you're logging, then basically kind of do some processing of that logging, and then you can flag like there is some kind of suspicious activity or something, okay. So this can help in kind of stopping security attacks. So this is very, very typical to kind of physical, right? When you enter some buildings, they ask you to write the name, yeah, when you came, yeah, that's logging, yeah. when you go, then also you check out. That's kind of monitoring. So in that process, basically they can find out like there could be some kind of suspicious person or something, okay, and there are cameras to monitor, okay. Similarly, think the same can happen into electronic device, yeah. When someone comes in, they must be authenticated, yeah, and then whatever they are doing, they must be monitored by a camera, okay. But in computer there is no camera, so it's just kind of some events that can be monitored. Okay, so what extra can be done? Anything else you can think of? Anything extra you can think of? Okay, I think we have covered most of it, but I will tell you just few things. So let's say like some security attack happens, right? Sometimes you can do post incident analysis, yeah, like sometimes some robbery happens, yeah, and then it's not stopped, yeah, it has happened, but police is looking recordings and everything so that they can put some mechanisms so in future it doesn't happen again, yeah. They will put some cameras on some security guards, yeah. Similar happens in computer, yeah. Something happened, do the analysis and think like when it happened what you can do. So it's like after the analysis you may think I can do monitoring like maybe every minute or every hour or every second, yeah. So this kind of mitigations can be done. And there is also, you know, like kind of a continuous security testing, yeah. So there should be some kind of software. It should always maybe on a regular basis, every monthly or something, it should keep checking whether there is only authenticated applications running, okay. Those kind of things can be done as well, yeah. Similarly, it's done in kind of in the physical world, right. So it's always kind of I mean you on a regular basis it is checked who are the people working into this, if anybody has done any criminal activities or something, yeah. Every year maybe there can be an audit, yeah. Okay, that's about that. So now key takeaways about the system design and operation for secure computing. So you can see here security is a life cycle. We have to think not during operation but at design as well, yeah, and we have to keep thinking it, okay. And threats evolve over the time, so therefore defenses must evolve, okay. You can see like every day there are new types of threats or new types of attacks, okay. So you have to think the defense in the same way, okay, and integrate security into every phase, yeah. So not only like design and operation, rather like I said audits, regular updates and all those kind of things, okay. Any questions there? Yeah, I think it's very generic, yeah. Maybe you do not have questions. Like I said, later we will go into more like the kind of approach, then you may have some questions. So now let's look the same thing, design and operation for sustainable computing. I don't know if we are up the time. I think we have 2-3 minutes, yeah. Let's do it. Yeah. So for sustainable computing, yeah. So again I try to put always questions so we can interact. So how sustainable issues originate from system design and operation point of view, yeah. I think some of it we have discussed, yeah. Like if you are irresponsible, like you are not aware, like we are doing so much carbon footprint, yeah. So unawareness, kind of irresponsible behavior, those kind of things can be there, yeah. So let's look at. So top reasons for sustainability issues, yeah. So one is rising hardware demands, yeah. So you saw the curve, right? The number of hardwares needed are a lot, yeah. And nowadays you can see like NVIDIA is the kind of most valuable company, yeah, $4 trillion, I think $4.5 trillion. They got only because of rising hardware demands. Yeah, everybody wants GPUs, and they have so many orders. Even the top companies like Google, Facebook, Amazon, Microsoft, they are buying their hardware. Yeah, they are making Nvidia more rich. So, and this is like they are producing more and more hardware, and that's not good for sustainability. Yeah, and why this is happening? It's mainly because of the rising software demands. Yeah, we want more AI processing onto these hardware, and we want more streaming. Yeah, like Netflix, Amazon Prime. Yeah, everybody wants to develop their own platform. Yeah, YouTube. So lots of AI processing, lots of streaming on these hardwares. Okay. Sorry.
Better communication hardware.
Yeah. Communication hardware. Yeah, they are also. Yeah, I think. Yeah, that's the thing. So hardware is. I mean, we are talking mainly computing, but there are communication hardware as well. Yeah. So there are upgrades into the routers, communication hardware as well. Okay. Yeah. Okay, these are the top reasons. Yeah, we want more hardware. The reason is there are more complex AI algorithms and more streaming and everything to be done. And also I saw there are lots of apps to do the same thing, right? And sometimes we have all the apps and we really don't need it. Yeah, and so basically we should not install unnecessarily apps. Yeah, okay. And this AI is kind of a race nowadays. Everybody wants their own chatbot. Yeah, Google has their own. Meta, now in Facebook in WhatsApp as well, Meta has integrated. You can ask anything. But essentially everyone is doing the same. Yeah, Microsoft has Copilot. So this is not really needed. Yeah, but it's kind of business model and everything. Nobody can stop. Yeah, so there will be rising demand for hardwares, and because of the rising software needs. So this is going to happen. So what should be done? Okay, let's look. So first thing we could think of is hardware efficiency. I think some of it we have discussed. Yeah, so no need to go through again. We should have energy efficient CPUs and GPUs. Okay, and there is something called adaptive performance scaling. So it's like, if my CPU doesn't need to run at the highest frequency, I should run it at the lower, so it consumes less power. We should have modular design. Yeah, so it's like there are many modules to make one system, but if one module fails, you replace it with something else. Yeah, so you can upgrade the components easily. Data center and infrastructure, again this is important. So one thing that kind of can be done, in place of processing the data on the cloud, you can try to process as much as possible on the edge. Yeah, it's like near the sensor. Yeah, where the data is collected. But because there is not enough resource, there is limited resource, that is why data is sent to the cloud. Yeah, imagine the example of this Google Maps. Yeah, you cannot run it if there is no internet. Yeah, so it's kind of, when you zoom in, if there is a local map stored, it will work. Yeah, but you cannot store the whole map. So when you zoom in or zoom out, there is a request that goes to the cloud, and then there is a response. That is why you get kind of zoomed in or zoomed out image. Yeah, because that kind of thing cannot be done on the local device. Okay, there could be more advanced cooling. Yeah, so you saw this, Google did some advanced AI based cooling, right, and that reduces their cooling cost by 40%. So that kind of thing can be done. And network segmentation and isolation, this is kind of related to security, if you remember. Yeah, again for software design. Yeah, similar to hardware, we should think about the software as well. We should not have a very heavy software for doing something very small. Yeah, so you might have seen this in your BTech, order of n square. Yeah, order of n cube, order of something. Yeah, so you should always have lightweight software, so it doesn't take a lot of power. Okay, there is something also called energy efficient coding. I think no software programmer does it. Yeah, so they just care about the functionality, but now this kind of research is picking. So like let's say if you have two entities, like two operands A and B, yeah, two variables. So A has like 12, maybe B has 10, yeah. Although if you multiply 12 by 10, it's 120, yeah. So if you do 12 by 10, the power consumption of that is different than 10 by 12. So the kind of order in which you multiply, their power consumption is different. So this is called like energy efficient coding, yeah. So some people know it, some people don't know it. So let's say if you are multiplying 3 values and you always know value of variable A will be highest, you should always put that on the first left hand side, okay. So this kind of practices needs to be done to kind of, even if you are not making the software lightweight, but you are making energy efficient codes, okay. Load balancing and scheduling to minimize waste, yeah. So you always know, like we kind of try to do things in as minimum resources as possible, and to meet the performance requirements sometimes we have to do load balancing, yeah, okay. Okay, I think we will stop on this one after just doing this. So network and storage design, so we can do efficient data routing to reduce hops, yeah. So data doesn't have to travel a lot, because if you are traveling a lot you are burning fuel, you can say, yeah. And there could be storage tiring, so hot versus cold data, yeah. So hot data is something like you always need that kind of data. That is why in computer you see there is memory hierarchy, right. There is cache, then DRAM, yeah, and there is multiple level of cache, yeah. So that is basically storage tiring, yeah. So if you are accessing something more frequently, if it's near the cache, it takes less power, yeah. And if you go to the main memory, then basically it takes more power. So this is something I like an example someone explained in a way, like you need some food, right. So some people get the food from the supermarket, put in the fridge, yeah. So if you get it from the fridge, it's like your cache memory, yeah. But it doesn't have a lot of space, yeah. It's fast, you don't travel, you don't have a lot of carbon footprint, but some of the things are not in the fridge, yeah. So the one that you need frequently you put in the fridge, yeah, maybe milk, bread, something like that. But there are a few other things you don't always use, that's in the supermarket. So always have this kind of storage tiring, okay. Materials and life cycle, again use recyclable low impact materials, yeah, and design for repairability, like when something fails then you can repair it, and e-waste management can be done from day one, yeah. Okay, and energy management in operation, yeah. So I think some of it we have seen. So you should always monitor the power consumption of each organization or each electronic, and you can always do dynamic resource allocation, yeah. So it's like I said, if we are here, these ACs should be on, but if we leave, that they should be turned off, yeah. So this is like two phase, yeah, but it could also be, if this room is so cold, there could be dynamic adjustment of the temperature itself that can save the power, okay. Renewable integration, so like I said, this is a lot of energy is produced by renewable resources, but like I said, this is not always available. So when it is available, then basically schedule the task to that kind of resources. So some data centers these days are running like that. So they operate on fossil fuels or electricity, you can say, but there are times there is huge amount of energy available through renewable resources, then energy is taken from that source. And always decommission idle servers, yeah. For example, there could be lots of laptops, lots of computers, those things, and lot of servers, yeah. So decommission them, basically don't put there, try to use for some other purpose, okay. Okay, let's stop here, and in the meantime think like what extra can be done, yeah, for sustainable computing. If you are designing the system, or when you are using the system. Okay, then in the second half we start from there. Okay, all right. Okay, so we meet at 2. Yeah, okay. Okay, have a good lunch. See you at 2.